This question is all about the modulus function and drawing graphs of the modulus function and solving equations with it. And I think we'll just sort of dive straight in. You can see the equation of the modulus function we're going to be dealing with there. So we've been asked to sketch the graph of that function. So let's just write the function out. So there's a couple of ways that you can think about this. You can think of it as a transformation, if you like, of the standard mod x graph. I'm going to sort of build it up, I think. So this might be a rough sketch to begin with. So what does y equals 2x plus 9 plus 3 look like? So in fact, let's leave the plus 3 to the end. I'm going to do y equals mod of 2x plus 9. So 2x plus 9 would look like this. Passing through 9 and minus 4.5. So the modulus is going to take this negative bit and reflect it upwards like that. So you have that classic V shape. And then I'm going to use that plus 3 and think of that as a transformation of this graph. So we've got this V shape, which is our mod 2x plus 9 graph. And then plus 3 is going to bring that up to something approximate, roughly that. So it's gone up by 3, and the coordinate of that point there is going to be minus 4.5, 3. So to draw it a little bit more clearly, my graph needs to look like this, passing through 12, and the coordinates of that point, minus 4.5, 3. Okay, part B asked us to solve an equation. So let's just have a look at that. There's the equation we've got to solve. 3x plus 1 equals 2x plus 9 plus 3. Well, that's the graph that we've just plotted. So it might be useful to bring back that graph and have a look at how it interacts with the graph y equals 3x plus 1. So here's the graph from part A. Remember, this one has got a gradient of 2. So less steep than the graph with the gradient of 3. The graph with the gradient of 3 is going to pass through 1 and it's going to go up steeper. So you can see that up here somewhere will be a crossing point of these two graphs, but there's no crossing point for that bit there. Okay, the graphs just get further and further away from each other. They're never going to meet. So what we're really looking for here is the intersection of y equals 3x plus 1 with the normal part of that, so not the sort of negative. You know, with the modulus, you kind of get the negative part of the graph and the positive part of the graph. The positive part of the graph sort of hasn't changed. The negative part of the graph has been sort of reflected upwards. So I'm going to ignore this part of the graph and just focus on this part here, because where they cross, that's somewhere up here, is going to be our crossing point. So what does that mean? Well, it means that I can solve them. Just take the modulus symbol away because it's that positive part of the graph. It hasn't been reflected. So it is 2x plus 9 plus 3, which is 2x plus 12. And then solving this very simply, take away 2x from both sides and minus 1. Okay, part C. says there's a straight line with the equation kx plus 1, where k is a constant, given that L does not meet or intersect the graph from part A, find the possible range of values of k. So I'm going to do another quick version of that graph, I think. So remember, that's 12, that's minus 4.53. And what we're saying is that any graph that, remember they said y equals kx plus 1, and we're told that any line passing through here is not allowed to intersect that one. So it can't be like in part B, it can't be steeper, because then it will intersect. So its gradient has a top limit of that, doesn't it? Right? Well, remember the gradient of this one is 2. If this line, dotted line that I've drawn, was any steeper than that, if it was more than 2, then there would be a point of intersection. So this value of k, right, where the gradient is equal to 2, that seems to be an upper limit, can't be steeper than that. What about a lower limit? Well, if you think about it, if you watch my pen, right, so that's a gradient of 2, it's not going to intersect. Any steeper, it will intersect. It can get less steep, 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 and then it gets to a point here where it starts to cross that point. So the other limit on this is the gradient of this line. Anything between those two gradients is going to be fine. So I'll just recap that with a pen. Look, that's 2. Steeper than that is not allowed. Less steep, less steep, less steep, less steep, less steep. All fine, all fine, all fine, all fine. But then it starts to make a point of intersection, doesn't it? So that is the minimum. So what we've got to do is say that k is got an upper bound of 2, but the lower one I'm just going to work out. So let's focus on these 2 points that we know. We've got to find the gradient between them. So we've got the point minus 4.53 and the point 0.1. So to find the gradient of those 2 points, let's use this formula. Which way around am I going to do it? 3 minus 1 over minus 0.5, 4.5 minus 0. So that is 2 over minus 4.5, which is minus 4/9. Okay, so putting that all together into a statement for k, we know that k has got to be less than 2, but it has also got to be greater than minus 4/9. That is the final answer you need.